Okay, let's pick up at example 3. It says, find the unknown measures of angle A and angle C. Round the lengths to the nearest hundredth and angle and degree. So here we have A, B, and C. This one's worth 7.5. This one's worth 5. We're going to do 2 different methods. Method 1, let's use the Pythagorean theorem. So if we use Pythagorean theorem, we'll have A squared plus B squared equals C squared. 7.5 squared is 56.25. 5 squared is 25. Add those 2 together and we get 81.25 equals C squared. Take the square root of that. And our answer is approximately 9.01 because it said round to the nearest hundred. And so we know that this is 9.01 approximately. Then remember, we're trying to find the measurements of angle A and angle C. So if we found angle A, you can use several things. You can use tan, which is opposite over adjacent. Remember, we don't know the angle measurement, so it would be tan inverse of A is equal to the opposite, which is 5, over the adjacent side, which is right next to it, over 7.5. Remember, your calculator must be in degree mode. So when we do tan inverse of 5 divided by 7.5, we get 33.6, and it says round to the nearest degree. So that means that angle A is approximately 34 degrees. We also have to find angle C. I'll use a different color so you can see where I write it. C, we can use opposite over adjacent. Again, so I'm going to do tan inverse of C equals 7.5 divided by 5. And that one is approximately 56 degrees. So we have 56 for this one, 34 for that one. If you do triangle sum to double check if it's correct, it does give us 180 degree as the answer. Any questions? This is method 1 of using the Pythagorean theorem. Method 2 is we can use our trig functions to figure out the sides, but we're not going to go through that. I'm sure most of you probably use Pythagorean theorem. If you want to see the other method for the sake of time, use your look in your books or on the PowerPoint. Here it says the coordinates of vertices JKL are -1, 2, -1, -3. That's K and J, and 3, -3. That's L. So here's our figure. It is a right triangle. Find all the side lengths to the nearest hundredth and the angle measures. Well, we know this angle is going to be a 90-degree angle, so we can say K is equal to 90. Side lengths are pretty easy to figure out because we know JK, you can just count it because it's vertical. 1, 2, 3, 4, 5 units. KL is 1, 2, 3, 4 units. And I'm going to use Pythagorean theorem to figure out JL. So 5 squared plus 4 squared is square root of 41, which is approximately 6.4 up. Now I got to find the angle measurement, so this is when we have to use tan inverse. We know this is 5 and this is 4. So I'll use L. So tan inverse of L is inverse because we find an angle measurement will be opposite is 5, adjacent is 4. So 5 over 4, tan inverse 5 divided by 4. That angle measurement is approximately 51 degrees. And so that is L. And then we also need to find angle J. So tan inverse of J Opposite is 4, adjacent is 5, so it's the flip of that. And so that is 4 divided by 5, and that one is approximately 39 degrees. Use triangle sum, 39 plus 51 plus 90, and that is 180 degrees. And so that is all the angle measurements and the side lengths. I'm going to pause it so you can make sure your work is correct. And pause now. And the final one is a real world problem. San Francisco Lombard Streets is known as the crookedest streets in the world. The road's 8 switchbacks were built.
Teachers, please excuse students from bus 96. The bus has just arrived. Please excuse students from bus 96. The bus has just arrived.
Were built in the 1990s to make the steep hill passable by cars. If the hill has a percent grade of 84%, what angle does the hill make with a horizontal line? So the streets are really crooked. It says that it has a percent grade of 84%, which if we wrote that as a ratio of fraction, that's 84 over 100. And then it also tells us what angle does the hill make. So if we know it's 84 over 100, so we have the crooked street. We know that the height is 84 over 100. And we're trying to find what angle does the hill make with the horizontal line. So in this case, we're trying to find this horizontal line right here, so I'll say A. So we're trying to find angle A. Tan inverse of A is equal to 84 opposite over adjacent. And so tan inverse 84 divided by 100. That angle is approximately a 40-degree angle for that street in San Francisco, and this actually is true. If you look in the book, you can see a picture or on the PowerPoint, and that pretty much sums up solving right triangles.